Welcome back, welcome back, welcome back. I'm Miss Lisa, and this is my YouTube channel for all things math and science that I want to talk about. Not everything. I'll admit it, there's some things I don't really care for in science. I really don't care in biochem what happens to the hydrogen in the cell membrane. I remember disliking learning that back in the day. I'm still not crazy about it, but this I do like talking about. And this time we're going to talk about gas laws. And there's a song. The gas laws are good to know. You can use them everywhere you go. We're talking PV equals nRT. We're talking heavy duty chemistry. I know, I'm a great singer, right? There's a reason why comments are turned off. Yep. All right, so we're going to talk about gases. Gases. So this is part 2 for what I've been talking about, but this is the gas part. Okay, so the first thing we want to talk about is that there are different phases of matter. So, and the gas is one of them. Oh, still have it on erase. Let me put my board back on draw. Okay, there are phases of matter. And if you were here with me, I would make you tell me the answers to this. Phases of matter. Okay, the first one is, let's see if I can, looks like it's really white there, but maybe y'all can see it. So the first one is, it's in a crystal lattice. It has a definite shape and volume. It has lower heat and energy, and the atoms can only vibrate. They can't move around. They just move until they get to absolute zero, where theoretically they stop. Solid, liquid, or gas? That's right. I'm sure you said it. That's a solid. Okay, the next one, the molecules are free to move around. They take the shape of its container, but it has a definite volume, so it doesn't fill the container. It just takes the shape of the container it settles into. Which one's that one? Solid, liquid, or gas? That's right, it's a liquid. Okay, the next one, the molecules are free to move around. Jump around. Everybody jump around. That's the one we already did. Okay, the next one, they are free to move around. They move faster. They take the shape and fill its container, and they have high energy. Solid, liquid, or gas? That's right, it's gas. And that's the one that this video is about. So we're gonna put a little star by it. And there actually is one other type of, oh, look, I'm writing out. There's another state of matter that's not very, you don't really think about much, but it's called plasma. It's very high energy. The atoms move very fast, and it's in fluorescent lights and also in the stars and the sun and things like that. So not one we think about much. Now, this is called a phase diagram. I'm going to move it up some so you can see it better. Give me the mover thing. There's the mover thing. It's funny, it always jumps down. There we go. All right, so here's the phase diagram. And in it, this is the pressure and that's the temperature. So whether or not something is a solid, liquid, or gas not only depends on temperature, but it depends on pressure. And we're used to always being under 1 atmosphere, so we don't think about it, but there is. So if you go between ice and water, that's melting. If you go between water and gas or water vapor, that's becoming steam. But there's this one point called the triple point where they all three meet. So you actually can go from ice straight to vapor, and it's called subliming. And I talked about that in the other video, so you can go back and see that. Now, these are the gas laws. Okay, that we're going to talk about. There's more, but these are the ones we're going to talk about, because remember, we talk about everything I want to here. The first one is Charles's law, and it is that there's a relationship in a gas between temperature and volume. When temperature goes up, so say imagine you're heating up a balloon, what's going to happen to the volume? It's going to go up. The balloon's going to get bigger. I used to do an experiment where I would get a Mylar balloon and wait till it had kind of gone flat, and you could take it and put it on a hot plate, and it would heat up again and fly again, because the volume would go up, which would make the density go down and the buoyancy go up, and it would fly. So if the temperature goes down, the volume goes down, and that's what Charles' law is. Now here's the formula. It's V1 over T1 equals V2 over T2. the temperature is in Kelvin, and how you get Kelvin is Celsius plus 273. This is going to be a simple cross multiply and solve for x. You'll be given 3 of these things and not 1, and whichever one it is, cross multiply and solve for it. We'll be doing practice with that, but all of these are easy math. Okay, the next one is Boyles Law, and it's that pressure and volume are related. And with his, it goes opposite. If pressure goes up, so imagine you've got a balloon and you squish it, you can make the volume go down, can't you? You can squish a balloon and make it smaller. So if the pressure goes up, the volume goes down. And if the pressure goes down, the volume goes up. It's an inverse relationship. And the formula is P1 times V1 equals P2 times V2, which in same thing, you'll be given 3 of these and you just solve for the 4th one. Easy, easy. The next one is Dalton's Law of partial pressures, and it's just, that's fancy science talk for pressures add up. They add up. And the greater the density of the gases, the greater the pressure. So what that means is, imagine this. I've got a balloon full of nitrogen. And then I don't take any nitrogen out, but I squirt some oxygen in. It'll be under greater pressure. The pressures add up. And then imagine I squirt in some argon. It's more fun with sound effects. It's going to have even more pressure. So the equation is pressure total equals pressure 1 plus pressure 2 plus pressure 3. Pressures add up. Okay? The next one, it looks like Gay-Lussac, but it's Guy-Lussac. That's how you say it. There's a relationship between pressure and temperature. If the temperature goes up, the pressure does what? It goes up. Imagine that you've got an aerosol can and you heat it up. It can blow up. In Georgia, sometimes we're not so smart. And there were some people up at the lake, not Alatoona, but Lake Lanier, and they had gotten a keg of beer. It's like a big, giant can of beer. And they had drank it all, so we don't know about their mental state at this point. But they thought, wouldn't this be smart or fun to throw the keg now on our campfire? Well, it wasn't empty. It had gas in it. And as the gas heated up, the pressure went up. As the temperature went up, the pressure went up. It exploded, and I think it killed some of them. I know they got hurt, but I think some of them died. So, I always try to point out things that are safety concerns, and that's one of them. So if the temperature goes down, the pressure goes down. And the formula is P1 over T1 equals P2 over V2. T2, I can say it. They'll give you 3, cross multiply, solve for the other one. The ideal gas law is that these factors are all connected. And you can tell that when I was telling you about the balloon. And there's a formula that connects them all. It's PV equals nRT, the one I sang to you earlier. P is pressure, V is volume, N is the number of moles, R is a constant, 8.3140, and T is the temperature. So that is that. Okay, now then, last little bit here. We live in a sea of air. You don't think about it because you're used to it. You've always lived in this sea of air, the atmosphere. Our atmosphere is approximately 80% nitrogen and 20% oxygen. Now, not exactly, because there's other things like carbon dioxide and other gases. One is ozone, which is O3, and it's an important shield for our planet. It helps protect us from harmful radiation. But we struggle sometimes with it getting a hole, and I used to have kids panic. Oh no, it's got a hole, but don't worry. Our planet makes more by lightning. Lightning, that smell, if you've ever been around and smelled after lightning struck, what you're smelling is ozone. Also, copiers make it. So yeah, it gets depleted, but it gets repeated too. And on Earth, it's actually considered a pollution. You're not supposed to breathe that smell near the copier. So because of the sea of air, we're under great pressure. It's all pushing down on us, but we grew up with it, so we're used to it. But I like to point out how much it is. It's 14 pounds per square inch. So imagine 1 little inch on your palm, 14 pounds of pressure is on it right now from the atmosphere. On your stomach, which is a square foot, there's 2,000 pounds of pressure. And if we took your little body without a spacesuit and threw it in outer space, you would pop like a piece of popcorn. So you're just used to it though. STP stands for standard temperature and pressure. It's 0 degrees Celsius and 1 atmosphere, what you're used to living under. All right, so science is great, math is great. Come back and we'll talk more about science. See you soon.